All right. Hey, okay. All right, 4 you skip. So we're not doing natural logs. You will do them. You don't graph in im3. You don't graph them. It's pre-cal. Okay. Unless they kind of changed it. Okay. All right. So here we go. If I look at number 1. All right. So the first thing you're gonna do is you have these logs. I'll do number 1 and then I have to do the second one because number 1 is like 3 and 8 and 9. Okay, so the reason why 1, 3, 8, and 9 are the same is, do you see that there's only one log?
Oh yeah.
Okay, right? Okay, so the one I'm going to do for number 1, I could kind of pause and you guys could take like 15 or whatever minutes and give 3, 8, and 9 a shot. Okay, so then 2, 5, and 7 are the same because see how there's multiple logs? They're going to expect you to use these properties. Like, see how you have an addition? Oh, wait, sorry. See how you have an addition here? They want you to use the product rule to get it first as a multiplication. And then it's going to look like number 1 and 3 and 8 and 9. So here, see how there's a subtraction? They want you to use the quotient rule for the subtraction to create a fraction. And now you have one log with a fraction, and so now you can make it look like these examples here, okay? So the right example is you have to use one of your log properties to make it first look like the left, and then you can start solving it, all right? All right, so let's do the first one first. All right, if you guys remember how to write logs into exponential form, do you guys remember it's your base? And do you guys remember you kind of do this counterclockwise rotation? So where's my paper? Let's write on paper. Okay, so on the problems for the pages you guys did, this was like early last week, if not the week prior. Remember, to go from log to exponential form and back and forth, it's your base, that's your exponent, and this is the argument or value. So I'm going to write 3 to the 4th power is equal to 9x plus 2. That's your rotation. And if you guys ever get stuck, just ask yourself, don't do 2's because I know you guys want to always go to 2's, but there's 2 2's, so that doesn't help you. So if you guys think of like 3 squared is equal to 9, or like 5 squared is equal to 25, you know, see how the numbers are all different? Okay, don't do 2's. All right, so if you guys ever get log base 5 of 25 is 2, 5 squared is equal to that 25. All right, just think of that. So usually if you kind of think back to this, you can get that down. So just kind of figure out or memorize one log, like say log base 3 of 9 is equal to 2. Like memorize that 392, and then you remember it's 329, and then that will always assist you if you guys are on a test. Okay. Okay, so what's 3 to the 4th power? What is it? You guys know. It's okay.
81.
81, yeah, because 3 squared is 9, so 2 9s, you get 81, right? Okay, so 81, 9x plus 2, and now you just have a 2-step equation. And so what do I do?
Subtract 2.
Perfect. And I get 79. And then you're going to get a decimal, right? Yeah, you're not going to get a pretty number. So you can leave it as 79 divided by 9. Oh wait, I can't see either. Or 8.7. So 79 divided by 9, or 8.7. And so that's your answer. That's it. And so if you were to check your work, I wrote too big, but if you were to check your work, if it's log 3, 9x plus 2 equal 4, okay, if I was to substitute not the decimal, right, because that takes out your significant figures, for those of you taking chemistry, right, 9 divides by 9, 1, so now I have 79 plus 2, right? Okay, that's 81. And now think about it. Do your rotation. 3 to the 4th power is equal to 81, and that is correct statement, right? 3 to the 4th is 81. So whatever your answer is, you can just substitute it back into x, compute it, figure out what that argument value is, and then see if that base to that exponent gives you that value. Okay, I'll give you guys time. I'll walk around, collect work, but this one is like 3, 8, and 9. Yeah, 3, 8, and 9. Okay. Let me